Hi, in this video, we're going to have a look at some examples of solving equations that have trigonometric functions in them. So we're looking for finding the angle, really, in this one. In a previous lesson, you should have already come across these two trig identities. We've got this one here, which says that tan is equal to sine on cos. And we've got sine squared plus cos squared is equal to 1. So they're the two basic trig identities there, and you should already be familiar with them before tackling this video. Just a note on notation, you don't have to have brackets around the input to the function like you do with other functions. I tend to put brackets around them just to emphasize that they are functions, but you don't technically have to because they're so common functions. But note that this means tan function where theta is the input, sine, cosine where theta is the input. It doesn't mean tan times theta. The other notation is sine squared theta. Remember, that means take the value of sine theta and square it. Take the value of cos theta and square it. You can't square sine without an input. So it's sine theta all squared. It's just a notation to make it cleaner to read, I suppose, without having too many brackets around. So just remember that. The other thing I just wanted to point out before I got into it is that please note that these expressions can be moved around. So, for example, it is also true that sine, I'll rub this out as well because I don't want it to be part of the main notes. Sine theta equals tan theta cos theta. I just did that by, multiplying both sides by cos theta. It's also true that cos squared theta equals 1 minus sine squared theta, etc. So be agile in your brain and make sure that you can flexibly see that there could be different arrangements of these identities to suit a particular problem. And you'll see that in one of the problems as we come across it. It's going to be split into 3 videos. This is the first video, which goes through some calculator usage. And in the second and third video, we just look at more complicated expressions, I suppose, or equations to solve. So here we go. Looking at example 1 here, it is from the textbook 12D, 1D. And there's a couple of things to note. Number 1, you look at the trig function that you're dealing with, in this case tan theta. You look at the value you need to get out, which is minus 0.76. There's the value itself plus its SIGN sign. And the last thing that's really important is looking at the domain. And you can see here we're looking for any solution of theta such that theta is between 0 degrees and 360 degrees. Okay, I've got my notes off to the side if you see me looking over this way because I've already prepared this so that I don't waste too much time fluffing about. So here we go. The first thing I guess we'll do is we'll work out the theta hat, the reference angle. I can tell that it's not, well, I can tell because it's negative here, it's not going to be an acute angle because everything is positive in the first quadrant where it's acute. So I know it's not going to be acute, but I do need to work out that acute angle so that I can go from there. So I can go tan theta hat is equal to 0.76. So I just ignore the sign, but the value stays the same, 0.76. And therefore theta hat equals, and if this was a recognizable exact value, like root 3 on 2 or root 3 or 1 in the case of tan, then you could be tempted to find the exact answer. But 0.76 is just kind of like a random decimal, right? So we're going to have to use our calculators in order to work out what that reference angle is. So I'm going to switch to my calculator, like so. And this is just a brand new document. And by default for my calculator, the calculator is expecting radians, and you can see that up here, that it's expecting radians. Now, there's a couple of things you can do. Either make sure you're really, 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 really clear on looking at the top of your document to make sure that the angle is in the right measurement. And if it says, if you need to be working in degrees and it says radians, you simply use your touchpad here to go up to the top here and click on rad, and it will turn to degrees. And you click on it again and it will turn it back to radians. So you can do that as well. One piece of advice I've given in previous years is to always keep your calculator in radians for your graphics display calculator and keep your calculator in degrees for your scientific calculator. So if it's in degrees, reach for your scientific calculator, and if it's in radians, reach for your graphics display calculator. But if you know that you're going to be fine to remember to switch it to the right degree, then obviously just use your graphics display calculator. It's a lot easier. So we know that tan theta hat is equal to 0.76. So we need to work out what that angle would be if it was an acute angle. So all of our trig functions are found under this trig button here, including our inverse function. So I'm going to go tan inverse 0.76, close the bracket, don't really have to, you can just press enter, and there's the value there, 37.234. Now in the question, in the textbook, it says to 1 decimal place, so that's what I'll do as well. I'm just going to write this down and then I will switch back. 37.2 degrees. Make sure you put the degree symbol in, because if you don't put the degree symbol in, it's assumed to be radians, so your units would be wrong. Okay, but that is the reference angle. We need to work out the actual angle or angles. So over to the side here, I'm going to draw my unit circle axes like so. And what I tend to do is I just tend to think, well, where is tan positive, where is tan negative? In this instance, I need tan to be negative. So I'm going to tick, or you can cross this up to you, the regions or the quadrants, sorry, where tan is negative. So if you remember the diagram, it's all students take care. So that would mean that sine is, or everything's positive here. Sine is positive here, which means that tan is negative. So this is a legit spot. Tan is positive here, all students take, and cosine is positive in quadrant 4, which means that tan is negative in this quadrant as well. So our angle is going to be either from here to here, from here and finishing in here, or from here and finishing in here. So if you want to, you could draw those lines on this little axis as well. So I might draw a little red line here to say it could be that one, or it will be, let me choose a green one, it could be that angle there, one of those two. So drawing it is really quite a powerful way of you connecting what you need to do without learning lots of complicated rules. So I can see from here, for example, that if the reference angle is going to be in here, so I'm going to have to subtract the reference angle from 180 to get this angle. So I can go, therefore theta is equal to 180 minus 37.2. And 180 minus 37.2 is a calculator operation, which would give you 142.8. I've got it over here, degrees, on my notes already, but let me show you on the calculator how to do that, because it's probably useful. So if I go 180 minus, and I want to get to this value here, so I don't have to keep on going back to it, I can just press the up arrow, and then I press enter. And if I press enter, the whole big value goes in there. It's kind of better than just putting in 37.2. Press enter, and it's 142.8, as you can see, the 2 decimal places. What's the other one? Again, not again, because I haven't asked you to do this before, but it is quite useful if you can remember to pause this video and try and get ahead a little bit if you get a sense of what you need to do. So I'll go on to slide 3 to do this. So again, feel free to pause and get ahead. Theta is also equal to, let's have a look. We've got the angle that's going around here and ending at this line here, like so. So it's really going to be 360 minus the reference angle. Remember, the reference angle is always the angle between the x-axis and the line, okay? It's never from the y-axis. So we've got 360 minus that reference angle. So theta equals 360 minus the reference angle. So was it 37.2? And that equals 322.8 degrees, like so. Again, on your calculator, I'm just going to use the up arrow, or I'm going to type, sorry, I'm going to type in 360 minus, up arrow, up arrow, up arrow, press enter, and then press return. And there you go, 322.8 degrees. Okay, that's example 1 done. In the next video, I'm going to look at example 2, which is going to be finding exact values and using our identities a little bit more. We didn't really use them in this one. And in the third video, we'll look at a more complicated video again.